Okay, so here in this video we will discuss about encoders. What is encoder? Encoder is nothing but a combinational circuit. Encoder is nothing but a combinational circuit which consists 2 raised to power n inputs and n outputs. It means that if we take n equals to 3, at that time there are 2 raised to power n equals to 8 inputs and 3 outputs. Okay, so encoder is a combinational circuit. Encoder is a combinational circuit that is used to convert 2 raised to power n inputs into n outputs. Okay, basically it is used in the transmitter side. Basically it is used in the transmitter side. We know that in communication, three basic elements are there. First one is transmitter, second one is receiver, and the third one is channel. Okay. When we transmit any binary data from the transmitter to receiver, so at that time when the data is moved through the channel, so in channel various noise sources are there that corrupt our data. Okay, so when these data is reached to the receiver, at that time there is a probability that this data will be changed. It means that suppose we are sending a data 10101, so because of noise the data that is received in the receiver may be 10111. Okay, and this probability of getting error the probability of getting error in the data will be high if the number of bits is greater. Okay, it means that if the number of bits in the message is high, so the probability of noise occurred in the data will also be high. Okay, so to reduce this probability of noise, it is required that we transmit a less number of bits from the transmitter. Okay, so how can we reduce the number of bits? To reduce the number of transmitted bit, we require this element, we require this combinational circuit, that means encoder. Encoder converts high bits, that suppose here 8 input bits are there, so before transmission the encoder converts 8 input bits into 3 output bits. Okay, if n equals to 4, so at that time 16 input bits are there and accordingly 4 outputs will be there. Okay, so if so if n equals to 3, then if n equals to 3, then 2 raised to power n, that means 8 inputs are there, and n, it means 3 outputs are there. Okay, so here I am making a block diagram. This one is known as octal to binary encoder. This encoder is known as octal to binary encoder. Why it is known as octal to binary encoder? Because here total 8 inputs are there. That means D0, D1, D2, D3, D4, D5 up to D7. Total 8 inputs are there. And because of these 8 inputs, total number of output that is represented here ABC, total number of outputs will be 3. Okay, that's why it is known as octal to binary encoder. Why octal? Because in octal number system total 0 1 2 3 4 5 6 7. In octal number system total 8 symbols are there. Okay, and here in this encoder total 8 inputs are there. That's why, because of the similarity, this one is also known as octal to binary encoder. Okay, so if I draw its truth table, if I draw its truth table, so we know that truth table is nothing but an analysis of input, and accordingly we will find out the number of output. So here total 8 inputs are there. So we need to draw, 8 input line. We need to draw 8 input line, that is D0, D1, D2, D3, D4, D5, D6 and D7. These are our 8 inputs, and accordingly we will get 3 outputs. That means A, B and C. Okay, so this one is the truth table of octal to binary encoder. This one is the truth table of octal to binary encoder. Okay, so this one is the truth table for octal to binary encoder. Is it clear to all of you? Now, from this encoder, from this truth table, it is clear that from this encoder, it is clear that from this encoder, it is clear that when D0 equals to 1, at that time, the output will be 0, 0, 0. The output will be 0, 0, 0 when only one input D0 will activated. Okay, but in the second case, when D1 equals to 0, at that time one's binary form, that is 0, 0, 0 will appear in the output side. Okay, when D2 is 1, D2 input is 1, at that time two's binary form, that is 0, 1, 0 will appear in the output side. Same case will continue for the other input number also. Okay, suppose here when D6 equals to 1, so at the time 6 binary form, that is 110 will appear in the output side. So it is clear to all of you. Now, after making a truth table, we will calculate the equation for output. Here how many outputs are there? Here 3 outputs are there, that is y0, y1 and y2. When we take the equation for y2, so we will check how many ones are there. So 1 2 3 4 ones are there, and this one will appear for 4, this one is for d5, this one is for d6, and this one is for d7. So for d2 the output equation will be d4 plus d5 plus d6 and plus d7. Similar for y1, when we check the column of y1, so 4 ones will be there. One appear for the D2, one appear for the D2, second one will for D3, third one will for D6, and the last one will for D7. And in the Y0, the output are D1, D3, D5, D7. D1, D3, D5 and D7. Okay, so this one is the output equation, for octal to binary encoder. Now on the basis of this output equation, we can draw. Now on the basis of this output equation, we can draw the logic diagram also. How can we draw the logic diagram? Such as when y2 equals to d4, d5, d6, d7. So first we have taken all inputs starting from D0 to D7. Okay, now y2 equals to d4, d5, d6, d7. So only we will take d4, d5, d6, d7, and we will provide to we will provide these input to first OR gate that consists four inputs. So accordingly, we will get y2 as output. Okay, in second case d2, d3, d6, d7. So this one is d2, d3, d6, d7. These are the inputs that we will provide to our gate having four inputs. So accordingly we will get y1. In the third case for y2, d1, d3, d5, d7. So this one is d1, d3, d5 and d7. These are the inputs to the OR gate. So accordingly here we will find out y0. Okay, so this one is all about octal to binary encoder. Thank you so much.